a force that opposes forward motion through the atmosphere and is parallel to the direction of the free stream velocity of the airflow, called a drag.
Drag is generated by 9 conditions associated with the motion of air particles over the aircraft. There are several types of drag. They are form drag, pressure drag, skin friction drag, parasite drag, induced drag, and wave drag.
Induced drag is the drag created by the vortices at the tip of an aircraft's wing. Induced drag is the drag due to lift. The high pressure underneath the wing causes the airflow at the tips of the wings to curl around from bottom to top in a circular motion. This results in a trailing vortex. Induced drag increases in direct proportion to increases in the angle of attack. The circular motion creates a change in the angle of attack near the wingtip, which causes an increase in drag. The greater the angle of attack up to the critical angle, the greater the amount of lift developed and the greater the induced drag. All of these types of drag must be accounted for when determining drag for subsonic flight. The total drag is the sum of parasite and induced drag.
Total drag of an aircraft is not simply the sum of the drag of its components. When the components are combined into a complete aircraft, one component can affect the air flowing around and over the airplane. Hence, the drag of one component can affect the drag associated with another component. These effects are called interference effects, and the change in the sum of the component drags is called interference drag. The parasite drag of a typical airplane in the cruise configuration consists primarily of the skin friction, roughness, and pressure drag of the major components. There is usually some additional parasite drag due to such things as fuselage upsweep, control surface gaps, base areas, and other extraneous items. Since most of the elements that make up the total parasite drag are dependent on Reynolds number, and since some are dependent on Mach number, it is necessary to specify the conditions under which the parasite drag is to be evaluated. In the method of these notes, the conditions selected are the Mach number and the Reynolds number corresponding to the flight condition of interest. Form drag and pressure drag are virtually the same type of drag. Form or pressure drag is caused by the air that is flowing over the aircraft or airfoil. The separation of air creates turbulence and results in pockets of low and high pressure that leave a wake behind the airplane or airfoil. This opposes forward motion and is a component of the total drag. Since this drag is due to the shape or form of the aircraft, it is also called form drag. Streamlining the aircraft will reduce form drag, and parts of an aircraft that do not lend themselves to streamlining are enclosed in covers called fairings, or a cowling for an engine, that have a streamlined shape. Skin friction drag is caused by the actual contact of the air particles against the surface of the aircraft. This is the same as the friction between any two objects or substances. Because skin friction drag is an interaction between a solid and a gas. The magnitude of skin friction drag depends on the properties of both the solid and the gas. For the solid airplane, skin friction drag can be reduced, and airspeed can be increased somewhat, by keeping an aircraft surface highly polished and clean. For the gas, the magnitude of the drag depends on the viscosity of the air. Along the solid surface of the airplane, a boundary layer of low energy flow is generated. The magnitude of the skin friction depends on the state of this flow. An important aerodynamic force during low-speed subsonic flight is the shear force caused by viscous airflow over the surfaces of the vehicle. This shear force is referred to as the skin friction force or skin friction drag and depends strongly on the Reynolds number, surface roughness, and pressure gradients. In addition to the pressure forces that act everywhere perpendicular to a body in moving air, viscous forces are also present. It is these viscous forces that modify the lift that would exist under ideal conditions and help create the real drag. Surfaces at angles to each other as in create turbulence in the region of the joint. This occurs most frequently at the intersection of the fuselage and wing.